Okay, guys. So let's talk about the lab that we're going to be doing there next week, just in terms of the kinds of tests that we're going to be running. So we want to use the physical properties of the materials in order to figure out their identity. And we talked about physical properties yesterday, things like color, okay, texture, even state at room temperature, odor, okay, that kind of stuff, solubility, pH, aqueous conductivity, okay, all of those things are going to be good tests for us to run, okay. So if I've got, these are some of the unknowns, I don't have them all ready yet, but I've got some of the unknowns up here, okay. So if I'm looking at, let's say, sample A, okay. All right, so is it crystalline?
Yeah.
Definitely. Okay, I can see this is crystalline. The parts of it are hard. Okay, but what's the crystal shape? Yeah, they're little like spheres. Okay, it's the only one of the unknowns that looks that way, so that's probably an important thing to help us identify it. That's something that's a little different about it. Okay, so what color is it?
White.
Yeah, maybe even just a slight bit off white. And it's got like a little tiny bit of like a creamy color to it. And it's not like brilliant snow white or anything like that. Okay, so we got kind of a off-white, spherical, crystalline solid. Right? What else should I observe about this? Any other observations I can make?
Solid.
Okay, it's solid. It's a crystalline solid. Okay, what else?
Never mind. I was gonna say pH.
I do want to do that. It's actually the last thing I want to do, but I am going to, pH is going to be a test that we're going to run. What else can I do without like adding anything to this or sticking anything in it?
Smell it.
I can smell it. Okay, now, when you smell an unknown compound, is there a technique for that?
Yeah.
Yeah, and it's not snorting. Okay? You are not to snort any of the unknown compounds. All right? Now, at the same time, the way that this procedure is going to go is that you're going to have all the unknowns in one of these. Okay? This is called the depression plate. And it's not because it's sad. Okay? It's just got divots in it. Okay? Depression where things can go. Okay? So you're going to put your unknowns in there. Is it going to be very effective for me to try to smell them when they're all together? No. So I would say like when you're doing the smell part, you probably want to smell the big sample at the front. Okay? And we want to do that by wafting it. Okay? If it doesn't have a very obvious, pretty much immediate odor, then it doesn't smell. Okay? Because I have people and they start this out and they're like, it gets to snorting at some point. Okay, you don't ever have to get to that point. If it's got a smell, you're going to smell it right away. Okay, there's no amount of like I need the airport drug sniffing dog to come in here and see if it's. We don't need to go to that level. All right, we just need to have a little bit. If it does have an obvious odor, that we record that. Okay, all right. So those would be kind of the immediately observable properties that it would have. That's our first test. Okay, it's the first test we want to run in our lab. What we call an observable properties test. It's the things that we can readily observe without really having to do anything to it. Okay? What are its kind of main obvious properties? All right. I've done everything I can with that, and I've got it in the dish. What should I probably test next?
Solubility.
Yeah, I test the solubility next. Right? And how do I do that in a controlled way?
Take a beaker of water and just slowly mix it in.
Okay, yeah, I would definitely want to get the water and bring it there. Do I want to use the same amount of water each time?
Yeah.
Yeah, okay, because that would be kind of like doing the procedure the same. It's a controlled variable, right? It would hardly be fair if I put 2 drops of water in one and then like dump a whole liter of water in the other. Well, no, they would hold it, but you get the idea. So I would say that, as a way to control this without having to do like constant meticulous measuring, that, we would cover the bottom with the sample and then maybe fill it with water to, 2/3 of the way full. okay? For doing that, it doesn't mean that we have to then measure everything, because that takes forever. If we actually physically measure out this many milliliters of water for each one, that would certainly be more effective, but it's also unnecessary for what we're doing, okay? We fill each depression to about 2/3 of the way full, okay? And then, once I add that water, are there any things I should do?
Vegetation.
Yeah, I should probably stir it in some way, all right? Now, stirring is done with these, okay? This is a glass stirring rod, okay? We want to use glass because it's not porous. If we use wood, it'll pick up the sample from one and then contaminate the next one, all right? So we use something like this that's not porous, okay, it's sealed, and then we can rinse it off easily between trials, okay? Is that something that should be included in my procedure? Yeah, definitely. Rinse the apparatus between trials, it's important. Okay, so I would be stirring it around, okay, and should I have a set period of time?
Yeah.
Yeah, I should probably have a set period of time, stir it for a minute, okay? And what else should I be recording while I'm stirring?
Temperature.
Yeah, I want to use a thermometer. You probably call it a thermometer, okay? But, okay, I would want to take this because sometimes compounds increase or decrease in temperature when they dissolve in water. That can help them to be identified because we said the other day that acids and bases both do that, okay? When you dilute them with water, they get hotter, okay? There's actually one unknown in here, it's gonna get colder when you add water to it, okay? So, I would say you're gonna have one partner who's going to like put this in there and just hold it in place, okay? And another partner who's going to stir, or maybe, you know, maybe you're really good and you can do both at the same time, okay? Just be careful, if you hit this together too many times, it probably will end badly. Okay, just kind of, but don't stir with this, that always ends badly. This is not designed to have stirring done with it, this is for stirring. These are cheap, these are not, okay? All right, what's the little red thing for?
Grip. Hold on to it then.
It is to hold on to it. It's not necessarily for grip. They're actually not very good for grip because they slide easily. Okay?
So
But-
it's your body temperature or whatever, doesn't it?
Yeah, it's rubber and it's an insulator. It keeps your body temperature from interfering with the readings. I see people doing this all the time. Okay, they're getting very inaccurate temperature readings because they're really warming up the thermometer with their whole hand. Okay, so yeah, you're better off, if yours doesn't have one of those little rubber things, hold it at the tip. Okay, very, very top, okay, and you'll interfere with it a lot less. The less of your fingers and hands you have on it, the better. Okay, so that would be your solubility test. Now, if I'm telling somebody how to record solubility, I'm obviously telling them to record any temperature changes, okay, but how do they know if it dissolves?
When you can't add anymore.
Well, I'm not gonna add more. I'm just gonna have it on the bottom and put water in. But like, what should I tell them to watch for as a sign that it's soluble?
The particles disappear?
Okay, so that the particles disappear, okay? Is it possible, if I've got the bottom of this covered and I only add about this much water, is it possible that the stuff is soluble but I can't get it all to dissolve? Yeah, it is, okay? And that's probably gonna happen with most of the samples. There's simply not enough space in here to put enough water in for everything to dissolve completely. So if it doesn't dissolve completely, what are some changes I might observe that indicate it's soluble?
If the water changes color.
Okay, any change, so if the water changes to the same color as the substance, that's a sign that it's dissolving. What else?
Maybe if it's like in a crystalline shape, if that's gonna break them down, if it's getting smaller.
Yeah, if the crystalline shape shrinks or rounds out, if it's square, if they start to get kind of round, okay, you know, any change like that is certainly an indication that it is dissolving. Those are the kinds of things you want to have in your procedure to tell people this is what to watch for. Signs that this substance is soluble include, okay, that, you know, it changes color to match the crystals, okay, or the crystals or substance changes shape, shrinks, okay, something like that. There's a change in temperature. Right, that also indicates that there's solubility, that the substance is soluble. All of those things are signs you'd want to record as an observation. Okay, everyone with me there? Okay, now that I've got a solution of that material, what should I test next?
Conductivity.
I should test conductivity next. Here's why I wanna do pH last. If I put the pH paper in there, are there chemicals on the pH paper?
Yeah.
Can they interfere with any other tests? Then I need to do pH last, okay? Because after I do that, the solution's no longer valid, let's say, okay? So, to test conductivity, I use this thing, okay? This is a 10-level conductivity indicator, okay? And it's got a little on button on the side here. When you press it, these ones are the new ones, they're awesome. They actually tell you that the battery is good by having a light that tells you it is on. Okay, which comes in handy because if you put it in something that has no conductivity and press the button, it doesn't light up. If there's no on button to tell you it's working, you won't know whether it was working or it just didn't conduct electricity. Okay, so that's pretty handy. All right, and you'll see it light up differently depending on what you put in there. So let's just do, I don't have any distilled water at this store. Okay, so I've just got, that's just water from the tap, okay? So I put my conductivity tester in there, okay? I get a conductivity of 4. Okay, so it's slightly conductive, and that's because obviously tap water has minerals in it. And I didn't clean this before I put the water in. Would that be something that might be important? No, I don't trust anybody. When it comes to science, I don't trust the person who used that beaker before me, did a good job of cleaning it. Okay, I always clean off all the stuff I'm gonna use first. All right, so it's got some conductivity, okay? If I add some salt to it, what should happen?
It should increase.
Yeah, the conductivity should increase, I hope. Okay, so if I was doing the solubility test, obviously I would have the thermometer in there as well. Okay, so I just give that a little bit of a stir. It's about 2/3 to 3/4 of the way full. Okay, that's dissolving pretty well. Okay, definitely less of it. Crystals are definitely changing shape and shrinking. In fact, I think if I was to stir this, for a full minute, I'd probably get it all to disappear. Okay, so that would be like our solubility test. Now, when you're doing this, do you have to be careful? Yeah, the most common source of error in this experiment is cross-contamination. Okay, people accidentally getting, a little bit of sample D and sample A. Right, so my recommendation is that you are very, 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 very careful when you're doing that. If that happens, just dump them out and start it again. Okay? All right, so I've got that all to dissolve. Sweet. All right, now if I put that conductivity tester in there, yep, definitely better. It's up to 7 now. Okay, you're gonna get some that are gonna read 10. Okay? Most of your compounds, if you're dealing with an ionic compound, your number should be between 7 and 10. Okay, if you're dealing with a molecular compound, you're probably going to be looking at 4 or less. Okay, I'm not going to say every molecular compound is going to be a 0. It's not. Okay, that our stuff isn't that accurate. Neither are these. Okay, but we're looking for low conductivity to no conductivity being molecular, and 7 or higher indicating that you've got an ionic compound. If you're getting numbers in between, you might want to look at either your solutions or grab a different conductivity apparatus. Okay, it might be fouled up or something. Should that get rinsed off between trials? Yeah, definitely. With what? Tap water or distilled water?
Distilled.
Yeah. In fact, anything that's going in these solutions should be rinsed with distilled water. You will have little wash bottles, little squeeze bottles, okay, that'll have distilled water in them that you can use for that purpose. Okay? All right. Last test. pH test. All right, so our pH paper is actually Hydrion paper, and it reads anywhere from 1 to 12, okay, on the pH scale. So you don't just have red and blue, right? This stuff will actually tell you what the pH is, not that it's acid or base. Right? So each one of these will have a little bit of pH paper in it, okay? And on each one of these is the color code to tell you which one it is when you're done. So this stuff here is probably going to come out pretty close to neutral, I would think. How many solutions can you test with a strip?
One.
We'll save some taxpayer money. You can test 2 with 1 piece. Okay? Now, when you do this, put it in and read it right away. The change is immediate, don't wait, okay? Check it right away, so if I'm looking at that, I think that's closer to 6, okay? It's probably between 6 and 7. All right, now, I don't want to be hanging on to that too long. You can already see the water's getting closer to my fingers, okay? Because this is table salt, I'm not worried about it, but if it's hydrochloric acid or sodium hydroxide, you probably don't want that to reach your fingers. So check it immediately and then throw it out, put it in the garbage. Okay, everybody with me on that? Okay. This is pretty straightforward? Yeah. All right, so you're gonna be testing, I think it's 11 different materials, right? So you're gonna have to use this tray twice. So you do like A through D and then do it again after that. Now, you can see that whoever used this one last left their labels on there, okay? So they wrote, you know, A, B, C, and D on the bottom. Okay, that's fine, okay? Just a little bit of hand sanitizer will take that right off. Okay, we've got a few of the little spray bottles of it in there. Just give it a spray and wipe it off with a paper towel and write the next 5 on there after. Okay, that is the best way to not get them confused. I don't know how many times I've had people, they send one group member up, they fill it all up, they come back, and they're like, well, which one's which? I don't know. Okay. I mean, it's fine if, you know, you got the green one and the purple one and the blue one, you can figure out which one's which, but how many of them are white crystalline solid? It's pretty hard to figure that one out after. Okay, so just make sure that they're labeled so you can tell. Okay? All right, so what we're going to be working on tomorrow is the pre-lab part of the lab report. So everybody will have a Chromebook, and you'll have your copy of that pre-lab, of the lab report I showed you earlier. Okay, and what you're going to do from there is you are going to get your problem written in. Okay, write your hypothesis, get your procedure written out. Okay, and that'll take pretty much all the class tomorrow after our quiz. We still have a quiz tomorrow. Okay, we should be able to get all of that done, and then Friday we might have a little bit more time to work on that, and we'll finish up naming completely. We're going to do a little bit of naming again here today just because we have a little bit of time. Okay, and then Monday we do the lab, and then we move on from there. Okay.
What's tomorrow's quiz on?
Tomorrow's quiz will be a naming quiz again. I'll probably have some questions on properties of compounds from yesterday as well. Okay, so you know, like properties of ionic compounds, molecular compounds. All right, so you'll want to review your notes on lesson 4. That was yesterday's lesson. Okay, as well as naming for tomorrow's quiz. I'll still post the practice quiz with the video. Okay. All right, so rest of class today, I would like you guys to do, we did those ones already, I think. Okay, so have you tried those 6? Okay, and then we'll go over them, and then I'll put 6 that go the other way. Okay, that give you the formula and go to the name. So formulas for those 6, please. Okay, let's have a look at these ones here. All right, so we got carbon dioxide. How easy is that one? Yeah, we didn't even probably have to think about the rules for that one. Okay, dinitrogen pentaoxide. How many nitrogens? 2. Okay, and how many oxygens? Right, okay, so molecular compound there. All right, 31, ionic or molecular? Ionic, but a little bit tricky because it's that funny one, okay? It's that weird polyatomic ion that acts like a metal. Okay, so I list it first. And then it is with carbonate that has a -2 charge. So when I drop and swap, I definitely need brackets around the NH4. Okay, it wouldn't be completely incorrect to also have brackets around the CO3 as long as you didn't put any other numbers outside of them. Okay. Questions on that one? Okay. And then we got aluminum oxide, so that's ionic. Al 3 plus with oxygen, -2, drop and swap, Al2O3. Okay, done with that one. And then calcium phosphate, also ionic because calcium's a metal, Ca2 plus. Phosphate is PO4 and it's a -3, so we got to drop and swap a 3 here, brackets, and a 2. And then lastly, chromium 3 phosphide, so chromium is Cr. The Roman numeral tells me this is the chromium that is 3 plus, and it is with phosphide, which is just P, and that is a 3 minus. Those already balance. CRP. Okay. Everybody all right with that? Nobody chuckled at that name. CRP. Come on. Say it fast. CRP. You're supposed to laugh at that. It's supposed to be funny. The dad joke, but I get it. All right. Okay, let's have you guys look at a couple that go the other way here. Have 38, 36, 32, and 39. Okay, those 4, and then we'll call it a day. So, first one here is ionic, and copper has more than one possible charge, okay, and it must be the +2 because fluorine is a -1, so this would be copper 2 fluoride. Okay. This one here also requires a Roman numeral. This would be the nickel with the 3 plus charge. Okay, iodide. And then we got our 2 molecular ones, diphosphorus pentasulfide, tetraphosphorus octaoxide. Okay, for those ones there. All right, so tomorrow's quiz, we'll have some stuff from lesson 4 and some naming. Okay. Practice quiz will post as usual between 3:20 and 3:30. Okay.